Two developers write code that does the exact same thing. Same output, same language, same day. One program finishes instantly. The other takes 10 minutes and crashes the server. The difference has nothing to do with how good the code looks. It comes down to one concept most developers never actually learn. Just memorize a cheat sheet for. That concept is big O notation. It shows up in every coding interview, every system design conversation, every why is this app slow debugging session. But most explanations either drown you in math or hand wave it with vague analogies. So here's the version that actually sticks. Big O notation isn't about speed in seconds. It's about how the work grows when your input grows. If you double the amount of data, does your code take twice as long, 10 times as long, the same amount of time? That growth pattern is what Big O describes. Imagine a locker with a number on it. If you know the number, you walk straight to it. Doesn't matter if there are 10 lockers or 10 million. That's O1, constant time. Looking up a value by its index in an array works the same way. Now imagine you lost your keys somewhere in your house and you have to check every room one by one. Twice as many rooms means twice as much searching. That's O of n. The work grows in a straight line with the input. This is what happens when your code loops through a list to find something. Now imagine comparing every person in a room to every other person in that same room, a huge group of handshakes. Add just a few more people, and the number of handshakes explodes. That's O(n) squared, and it's usually hiding inside a loop nested inside another loop. Last one, imagine guessing a number between 1 and 1,000. Instead of guessing one by one, you guess 500, get told higher or lower, then cut the range in half again and again. You'd find it in about 10 guesses instead of 1,000. That's O log n, and it's why binary search is ridiculously fast even on huge datasets. Here's the mistake almost everyone makes. They memorize the definitions but never learn to spot big O in their own code. If you see a loop, that's usually O(n). If you see a loop inside a loop, that's usually O(n) squared. Train yourself to read code and immediately see the shape of the growth curve. That's the actual interview skill, not reciting definitions. Big O measures how work scales as input grows, not raw speed. O of 1 stays constant, O of n grows in a line, O of n squared explodes, and O of log n stays impressively flat. Learn to spot these shapes in your own code, and you'll start writing faster software without even trying. This is video 2 of the full DevVerseX Data Structures and Algorithms course. Subscribe so you catch every concept in order. This series is built to stack, and skipping around will only make it harder. Next up, O1 versus O(n) versus O(n) squared, where we put every one of these complexities head to head with real code examples.